figure out what's going on. But there we go, just kind of a pretty sunset a few hours ago. Sun coming down through some stratocumulus. And I want to show you a little feature here from earlier. I'm going to run that little time sequence again and check out this area in the background. And if you keep an eye on that region back there, you'll notice the growing towering cumulus spreading out and becoming stratocu beneath a layer that's beneath a subsidence inversion there. So that's kind of where a lot of this stratocu is coming from. And we'll take a look at that in the scutees in just a moment. Okay. Here I am. Here's the webcam. And let's take a look at the charts. We've got a few thunderstorms out in the Oklahoma area and out around Texas. And before I get much further, let me find out what's going on with my levels here. Like the microphone levels are coming in a little bit weak. Coming in nice and solid. Yeah, something weird is going on here. Let's see here. Okay. Very confusing there. I'm getting good... Okay, that's the webcam up there on the top. Sorry about that. I should have taken a look at that before I went on the air. Let me take a look at my mixer here, see what's going on. See, these are the levels that look a little bit low to me here. I'm trying to figure out what's going on there. Beats me, I'll just bring them up a little higher and we'll just roll with that. How does that sound? Okay. So we've got thunderstorm development out around Oklahoma. Let's put on the surface plots here. And we see something a little bit unusual. A little bit of easterly wind. So this looks like the air behind a front. And there's the front right there along the Red River. And the air back behind that cold front is a little bit humid still. You can see we've got dew points in the lower 60s there. A little bit of lift and a little bit of instability, and we've got showers in place there. Let's take a look at the GR level 2. I'm going to go ahead and bring this up in the background while we look at the rest of the charts here. So GR level 2 coming up here. I'm going to set probably Frederick, Oklahoma. We'll get that going. And now let's look at the rest of the chart sequence. Okay, we've got a nice surprise for this evening. Look at that, max temperatures. Normally we don't get these until about 9 o'clock, so this is kind of nice to look at. And we can see the 80s we have in Texas and 91 right there at Cotulla. A lot cooler in Oklahoma, in Kansas, lower 70s for that region. So that kind of delineates where the cold front is. There's a quick look at the SPC mesoscale analysis. And we can see that little inverted trough right here. So that's kind of showing approximately where that cold front is. And how does the instability look for this evening? We'll bring up the plots right here. And this is coming from the rapid refresh model. And the values in this area look to be right around 1,000. So that's not very high. That's kind of in the moderate range maybe for instability. So these are kind of the values I'm looking at right there. And as you go further north, of course, you get more of the cool air in the boundary layer, and that's probably going to be more or less elevated convection going on there. Higher tops, or higher bases. And if we're going to look at elevated convection, what's best to look at is this most unstable cape. And that might show a little bit of the instability in that region. Let's see what comes up. Yeah, Got about 1,000 up there to the Kansas border, maybe 500, and things are pretty much cut off north of that line. So that's what you want to look at in a situation like that right there. Okay, 250 millibar, and this is another surprise. The Canadian surface analysis is for this evening instead of this morning. Another benefit starting late. So we're going to start out looking at that evening analysis. And before I get much further, let me take a look at the chat, see what's going on here. Got a pretty good crowd in here this evening, even though we're running a little bit late. We've got, let's see, Ahmed is here, and Alexi. And Kevin, Megan, John, checking in from Minnesota. Alexi in the middle of doing homework and mentioning that low audio. Hopefully that's fixed right now. But I've got to remember to go in there after this webcast and see what's going on. Greg Schultz is mentioning squall line going through Milwaukee this morning. 50 to 70 mile an hour winds. Lots of tree and power line damage in that area. Brett Dean mentioning Chuck Dowswell there, studying Chuck's... he's got a lot of great writings on mesoscale analysis. And one great book I would recommend looking at, and this is free, by the way. Let me show you how to get to this. It's going to go... What you do is you go to my website at weathergraphics.com/DL for download. And there's going to be a document in here. This is a document that I scanned for Chuck many years ago. And that's going to be down here in the bottom. See this Volume 1, Mesoscale Analysis. This is a great starting point for the type of weather analysis that we do each evening. So you can download that. It's a 40 meg download. I'm not going to do that right now, but that'll kind of start you out on the basics. It's slightly dated. These are like 70s and 80s type science, but it is definitely the fundamentals of mesoscale analysis, and I would definitely check that out. Okay, 250 millibar analysis showing a trough. There it is right there over the Rocky Mountain region. And we've been watching that for a while coming in, and there's the jet from Oregon down to Nevada. And then the other side of that jet coming out right there, southern Colorado, into Iowa and the Great Lakes. So we're starting to get some stronger wind flow out over the central and even the southern plains here. And we're starting to suck the subtropical jet into this action. And there it is right there. Very weak, kind of merged in, I guess, a little bit with the polar front jet, but that's it right there, subtropical jet. And then we go up to 500 millibars and we lose that subtropical jet, and we're picking up mostly the polar front jet right here. So we see that right there. The large-scale trough in Utah and Arizona like that. And then embedded in the circulation, some weaker shortwave troughs, maybe one there, one there. And there's probably one buried in here somewhere. 700 millibar chart for this evening. Do we see any of the capping? Well, this can be a good chart to use for your isotherms. So there's the 8 Celsius line. It's going to be running from South Texas up to about Lubbock, up to the Four Corners. And then the 10 line running like that. So to a certain extent, it's bringing some of the cap up and over the tropical air like that. And then as we go further back, this is where we find the polar front jet, or the polar front. So that's going to be maybe roughly kind of like that. And then we've got the 850 millibar chart. This chart is not really ideal because it's cut off down here in Texas. But we can look at this for now, and we can see the moisture coming up from the south. Okay, so this appears to be the 850 millibar front. And then as far as the readings down here on the bottom left, this can be problematic on a lot of charts because you don't know whether you're getting dew point depression or dew points. One way to figure that out is to go way up north and look at the readings there. See that 12 right there at Moosonee? Could that be dew point? Dew point at positive 12? No way. So we know that that's going to be dew point depression. In other words, the dew point up there is minus 14. So we got to keep that in mind. We're looking at dew point depression here. So basically values of dew point depression 5 or less are going to be associated with clouds. So possibly cloud material right there at Oklahoma City. And values below 5 or above 5 to 10, that's going to be associated with dry air, like what you see here. Okay, so there we go. That's the 850 millibar chart. Satellite. There's something you don't see very often. That's when we think of weather satellite imagery, we don't really think of this, but this is kind of like the imagery that we start with. And then we just kind of add things to that. So that was a visible image. If we want to add map data, we can easily do that. Now things make a little bit more sense here, and we can see a little bit of cloud material off the coast there. But at nighttime, we want to use infrared imagery. So there we go. That's what's going on right now. Infrared imagery showing a little bit of mid-cloud through here. This looks like altocumulus maybe. A little bit of high stratocumulus and altocumulus over Oklahoma and Kansas. And then, of course, the very cold thunderstorm tops right there over southwest Oklahoma, and more of it. A lot of debris cloud and old anvils in Colorado there. So we can see that this is a pretty new convection firing right there near Childress. Okay, let's go back to that radar and see what we got going on. Yeah, this is a good thing to show you. Look at that S shape to the velocity. We're looking at base velocity here. So what I'm doing here is I'm tracing the zero line and the radar site located right there. So what does this S tell us? We don't always have an S. A lot of times we just have kind of a straight zero line, kind of like that, just cutting right across. When we have an S shape like that, that tells us that we have shear. We have directional shear in the atmosphere. In other words, in the low levels, very close to the radar site where the beam has not gone very high, we've got flow out of the east. And as we go aloft, we have flow out of the south. So we can just kind of trace this and kind of see the wind with increasing height. So this right here, this is going to be at a height of about, it's going to be about 1,000 feet right here. So it's about from about 500 up to 1,200 where we have that shear, and then above 1,200 we have flow coming out of the south. So superimposed on that, we have the storm scale velocity. signatures like this couplet here. So here we have flow going away from the radar. Here we have flow going towards. So we've got a mesocyclone there. We have a rotational couplet right there. I'm going to drop a dot right in the center of that. And there it is right there. Meso located right there, helping to propel that RFD out across this region right here, and then this is the forward flank downdraft of this storm. Okay, so pretty simple there. There's the lowest scan showing that cell right there. This is just north of Vernon. And a new frame just came in. So this is the updraft base right here. So if you're chasing, you're probably going to want to be on this road here, checking out the action. But you're also going to be trying to figure out how you're going to get across this river, the Red River. That's always fun. Giant river plains like this. You're probably going to have to be thinking about going south in a big hurry, dash through Vernon, and then back up. And now we pick up some east-west roads in that area. Some chasers, they'll just head right up here early, go as far as they can out here, and they'll sit out here and just watch the storm heading their way. Okay, velocity in that storm, let's check that out. Velocities in the storm are not all that strong, but you can see we kind of lose the rotational signature, and we have more of a convergent signature here. So you see these strong outbounds right here. This is about 27 in, coming up against about 10 in. So about 40 knots of convergence in this area, kind of feeding this updraft base. There's the center of that convergent area, right there where that updraft base is. And let's check out spectrum width. Spectrum width is a very neat product, and this kind of shows us a little bit of the inflow air. It looks like this is probably all inflow air, and a lot of this diversity that you see here is coming from micro insects, believe it or not. Very small insects being carried aloft with the inflow coming into the storm. And a lot of that insect activity kind of suppressed in here. A lot of this air coming from the upper levels of the storm. Okay, what else is going on? Let's check out the other cells. Got another cell right here. And these are going to be kind of like, for the most part, slightly high base storms. They've got that, they've got kind of a classic supercell look to them. So here's this other storm. They've definitely got mesocyclones in them. We go up to the higher parts of the storm. This one, not so strong, but let me go back down and see what's going on. See a little bit of rotation right there. So the circulations in this storm are not really all that strong. This one here looks a little bit better. And what else do we got going on? These are going to be up further back north of the front. So they're dealing with a lot more cold air being ingested into that updraft. And these are starting to shut down here in northwest Oklahoma. Okay. Going back to the large scale picture. There's our front coming out of Oklahoma and the Texas Panhandle, and we've still got quite a bit of baroclinicity out over Utah and northern Arizona. We can trace that front even all the way back to Southern California there. We got to keep an eye on this area. Possible region of cyclogenesis right there, with that pinching that you see right there. And then, of course, we have another system lined up off the Pacific. And that'll probably be entering the picture soon. Okay, let's take a look at the soundings. We'll take a look at maybe Fort Worth. And I think they're going to be slightly south of the front. A little bit of a cap right there. In that time lapse that you saw with those towers going up and spreading, they're spreading beneath this inversion. Shreveport might show that up a little bit better. Yeah, you see a little bit more of that subsidence inversion right there. Those towers rising and spreading right there, up at about 10 or 11,000 feet. Okay. Let's take a quick look at the dynamics and see what's going on here. Okay, for this evening, there's that negative tilt trough out over the Four Corners area. Plunging polar front jet coming in from Nevada and northern Arizona. And some of the higher velocities emerging right there in New Mexico and Colorado. So we're starting to get a little bit of the stronger dynamics coming in from the Rockies. Overnight, we're going to see that spreading eastward. And then for tomorrow evening, got kind of a busy map here for tomorrow evening. Polar front jet along the Interstate 40 corridor. Stronger dynamics just north of that jet. This is the left front quadrant. So jet max located right there over the Texas Panhandle. And this is the divergent left front quadrant. So we're seeing a lot of lift in this area and enhanced potential for storms and showers in that area. Now, the right rear quadrant is also associated with upward motion, but the cyclonic curvature tends to cancel that out. So this is actually kind of indeterminate. Okay, then just over the weekend, what we're going to see is everything just kind of moving eastward out into the Mississippi River Valley, and we get kind of a channeled flow going on. Definitely supportive of strong storms, but not not those advection lobes like what you saw earlier in the sequence here. See, that's a shortwave right there, another shortwave. A little bit less of that as the weekend goes on, as things become channeled. Okay, let's see. What should we look at next? Let's take a look at the surface analysis. Get rid of some of this here. Okay, if we're forecasting weather overnight in Oklahoma and Texas, we're going to want to know where all the fronts are and all the boundaries. So here we can see some tropical air flowing northward through Dallas-Fort Worth, through Abilene, and it meets up with this front located right here. So that right there is the location of the cold front coming south. So some of these storms are developing behind that boundary. Others a little bit closer to the boundary, like that storm near Crowell. And let's see, what are we interested in as far as ingredients for severe weather? Well, the moisture axis is going to be a big one. Let's zoom out a little bit and check that out. And actually, while we're at it, why don't we get the latest data? Let's do that. So we're going to pull in the 10 p.m. data. Here it comes. And while that's coming in, let me take a look at the chat right here. Misty Sowards, it's a new name there, mentioning that Ohio rarely gets 60 dew points. Yeah, that's true. Brett Dean mentioning a gust front on the hook. Brett Dean mentioning West Ohio gets bad storms. 1974 Xenia. And let's see here. I'm just scrolling through the chat here real quick. And Brett says he lives in South Jersey, and mentioning a couple storms that he's seen in that area there. Okay. So there's our latest chart right there, showing the front through southern Oklahoma down to the I-20 area. And it looks like the Big Springs winds have just shifted, and now they're coming out of the south there. So the moisture axis, that appears to be located well out to the east. That's where we find the 68 and 69 degree dew points. As far as the storm situation we have going on in this area, let's see if we find a localized moisture axis. I don't see one here. It looks like just kind of a progressive decline in the moisture as we go west. So plotting the isodrosotherms. There's our 62. And then 64 is going to be like this. And then 66 is going to be out here. And then we find our 68, looks like probably out in this area here, up to Corsicana. Pretty much along Interstate 45 right there. So that's our 68. So maybe a little bit of a moisture axis right in this area. So this would tell me that along that boundary right there, most favored area for development, probably right there. Dry line, maybe a bit of a dry line. Possibly in this area right here, but we do have some fairly decent moisture out in the Midland area here, upper 50s dew points right in that area. But I want to keep that dry line to the east of that gradient as much as possible. So I might even go something like this here for the dry line. And where that intersects the front, that's going to be the triple point. A little bit messy there, but that tells us our triple point is up there near Knox City, Texas. And we can kind of tie that in with our radar. So that storm is probably the closest to that triple point, and it's starting to get kind of late, but this storm here would probably have the best potential out of all these here. Let's see what that cell's doing. Looks like it's heading southeast. So depending on what kind of pattern we have, we could certainly see a cell like that persisting well into the night if it's heading directly towards the moisture. Okay, so it's in the Crowell area to Seymour. Let's check that out on the surface map. Talking about this area right here. That's heading directly toward the moisture. So that cell has the potential to keep going for a while. So we'll keep an eye on that tonight and see what happens. All right. Since I just kind of walked into the situation, I think a good idea might be to load up some of the mesoscale models. I'm going to load up the high-resolution rapid refresh. And we'll see what that goes for. Okay, so this is going to be the 0Z run. This is based on the 7 p.m. data. So let's see what it's got for a forecast here. 2Z. 3Z going for a little bit of development right there. That's the area we're watching right there. What kind of trend is it going for? Going for a little bit of a decline south of the Red River, but it appears Oklahoma starting to pick up some activity, forming an MCS overnight, and then that moves eastward towards Fort Smith. And look at that, another MCS forming out over the Texas Panhandle there. See how that comes together? So what you'd want to be watching for is to make sure that the model is consistent with what it's showing here. Or you'd want to check and make sure that what it's showing here is consistent with the surface data. So right now I would expect to find shower activity around the Clayton area up towards Springfield. So those are some things I'd want to look for there. So it looks to be like a pretty active night here coming up, and model going for some activity there near Oklahoma City after dawn. I would say all these storms here have some potential to continue southeastward. Certainly these ones north of the Red River here. Okay, let's take a look at the synoptic scale forecast going into tomorrow. Okay. Starting to lose my voice there. Okay, for tomorrow evening, got a quasi-stationary front along the Red River. And all of this activity is increasing overnight into tomorrow because of the approach of these upper dynamics. The flow aloft becoming very strong, helping to generate long-lived cells and support organization of these storms. So for tomorrow evening, we're going to see quite a bit of activity up in Oklahoma. GFS going for a lot of activity there north of the Red River along the warm front. And then a little bit quiet there along the cold front because that cold front is in proximity to much drier air. Dry line will be probably coming up to the I-35 corridor, something like that. Okay, busy night for tomorrow night, and I am going to run extended hours, I think, on the webcast. We may start early, or we may run overnight. We'll see how it goes. But that surface low will push eastward into Arkansas overnight. Cold front coming through Texas, warm front right there. And by dawn, that'll be coming into the Memphis area. And then for Saturday's webcast, we're going to see things moving into Mississippi, Alabama, and Tennessee there. So a chance for some severe in that area. High pressure building into much of the central and southern plains and the Midwest. And quite a bit of cold air lurking to the north here. Look at that 540 line right there over the northern tier states and much colder air up to the north. Pretty unusual for this time of year. So a cool high pressure this weekend over the Central Plains. We get this northern U.S. system, Pacific system moving eastward like that. And it's starting to kind of infuse some of this cold air into the circulation there. Warm air coming from the south on Tuesday, cold air coming from the north, and that's helping to get some baroclinic development going there in Minnesota. That system deepens a little bit and kind of leaves the picture there. Then we're kind of left with this trough through the Central Plains. And then you can see the baroclinic boundary right there through Northern California and Nevada. This is around Wednesday next week. So that'll be the next potential area of development. Okay, then we get to the end of that chart sequence. I'm out of charts there. Let me reload it and see if we have any current, if we have any newer frames. Nope, I think we're stuck there. I'm going to go back to the 18Z chart and we'll just kind of finish out with the data for that hour. Might as well use that chroma key a little bit. Getting a little bit of bleed there. A little bit too much light hitting that thing. That'll be another thing to fix, but anyway. Check out the GFS here. I think we're done loading in the frames. Okay, for late next week, let's see what's happening. Looks like things are starting to get active on the Central Plains. And there we go. There's our next system right there over at Kansas. And this time of year, getting up towards May, I would expect to certainly see severe weather with anything coming through the central or southern plains this time of year. So Kansas next Thursday, watch out. And that'll be spreading up towards Iowa. Tailwind coming into Texas and possibly some severe weather there too. And then for the weekend, persistent cyclone right there in Texas. With the packing of this thickness right here, this tells us that there's going to be strong flow aloft. That's going to support storm organization. We've definitely got boundaries in the low levels. So this is going to be kind of a stormy weekend coming up here for the 29th and 30th. Looks like maybe a squall line right there in Arkansas and Missouri. And things are going to push eastward as the cold air sweeps in right there. Okay, then we get to the end of that sequence, and this is getting probably a little bit too far out. This is 372 hours out, but it does look like we're getting into an active weather pattern. And look at there at the very end, 540 line all the way down to the San Joaquin Valley. That's a very strong frontal system right there this time of year, and that's going to make it to the plains, and things should get pretty interesting around the 7th or 8th. Okay, well anyway, we're almost coming up to midnight here, so I think that's going to be it for me for now. Hope you enjoyed the WEATHERCAST, and I do have a kind of a neat feature. Let me show you this. We're going to close out with the sounds of nighttime in Texas here in April. And you're just going to hear the sound of things outside while we close out. Anyway, I hope you enjoy the WEATHERCAST, and we'll see you tomorrow.